Hi students, let us continue with the asymptotic notations. Now let us see what is the big omega notations. The two differentiable function f of n and g of n, say f of n grows with the same rate or faster than g of n. So in the big O notation, f of n grows with same rate or it faster than g of n. So it represents as f of n is greater than or equal to c into g of n. So here where n is greater than or equal to n naught and c is greater than 0, the constant is greater than 0, and put whatever the size of the starting should be greater than or equal to 1. So it at least 1. The input should at least 1. And this can be denoted by f of n is equal to omega of g of n. So this condition is denoted as f of n is equal to omega of g of n. Okay. So let me take the graphical notation. So here this is c g of n, and whatever the function, that is the input function we are taking, this is f of n. And this is the size of the function and this is the time taken to complete that particular function. At this point n naught is equal to n1. So this is a representation of f of n is equal to omega of g of n. So this completely lower bounded. This is a lower bounded. So what it represents? G of n is an asymptotic lower bound for f of n. So g of n is asymptotic lower bound of f of n. So let me take the example, the same example whatever I had taken for the theta and big O. F of n is equal to 3n plus 2, g of n is equal to n. Now the formula is f of n greater than or equal to c g of n. So f of n is 3n plus 2 greater than or equal to cn. So now n, what is the value I have to take, because this is lower bound. So here I am taking c as 1. Now 3n plus 2 greater than or equal to n. Okay. So this is here n naught is always greater than or equal to 1. So this you can represent 3n plus 2 is equal to omega of n. So this is a formula for to calculate the time complexity of big omega notation. So so far we have seen theta, big O and big omega notations. Now let us a simple formulas for this little o and little omega also. Little o. So this should be the growth rate is always slower. For little o, slower growth rate. So here f of n grows slower than g of n. Okay. So when if this condition is satisfied, limit n tends to infinity, f of n by g of n is equal to 0. Okay, formally you can state this little o as formally stated as f of n is equal to small o g of n. So this is a formula for calculating the little o time complexity. Now let us see the next one, that is little omega. Little omega. So this growth rate is faster. For little omega, the growth rate is faster. So here f of n grows faster than g of n if limit n tends to infinity, f of n, g of n is equal to infinity. So this is the condition, it has to be satisfied. So formally it's stated as f of n is equal to, this is a small omega, g of n. So this is the formula for little omega. So little omega is always faster growth rate and little o is slower growth rate. So this is about the different asymptotic notations. Thank you.